Right. I'll say, so how did the quiz go? Anybody have any questions about any particular problem on it? Again, if you're not doing this, you cram it at the last second. I don't know how well that's going to go for you. Hopefully well, but it can become a lot. Nobody has any questions? Number 5, solve that differential equation. So what would be your first step? Separate your variables. Just as a hint, I don't think I did it on my key, but remember, you only have to bring the y stuff over. It actually is a little easier if you factor that, I think. Like if right here, I'm not going to do that because most of you probably did not. But like if I'm able to take a 3 out and I only have to bring down a y minus 3, then actually I don't have anything to adjust on a u substitution. I don't have to put anything else in. It just looks a little better. Now your answer will look a little different than mine, but it will mean the same thing mathematically. So if you had done this and then take that 3 and just multiply that in, your answer might look a little different than what I showed, but I think it's a little easier that way, for whatever that's worth. But we'll just go ahead and pretend that nobody, did anybody see that to do that? Yeah, most people don't. Okay, so right here, dy over 3y minus 9, because you're going to have to divide that, and you're going to have to multiply by a dx. And then when you integrate both sides, that you would have to do a u substitution for. So you'd have to say, all right, u is 3y minus 9, because I need to make it 1 over u. So the du is 3 dy. So you would have to come in here and make that a 3 dy, adjust it with a 1/3, and then that would be your du, and that would be your u. So this would give me 1/3 integral of of u on the bottom, right there, and then du on the top or out to the side, depending on how you like to do it. And then when I integrate this, I'll just bring it down one more time. So once I get the u substitution ready, you integrate both sides, and you get ln, and you can multiply by 3 initially. I think I may have multiplied by 3 to go ahead and cancel that, so I wouldn't have had that there. But if you didn't do it, you have to multiply later. So I get ln absolute value of the u equals 3 times the integral of that, which is 6x cubed over 3, and minus 5x plus a c. So at this point, I'd probably want to distribute that out, which is, you could have multiplied that in as well. That gives you this. And 3 times c is just another different c, which is fine, right? And then you're going to have to exponentiate. Get rid of that. And then e to this is fine, but the c can swing out to the front. And then what happens to the absolute value? It makes a plus or minus in front of the c, which is kind of eaten up by it. So it's not really necessary. And then the last couple of things are I need to add that 9 to this side and divide by 3. And when I divide by 3, you could put c times that over 3, and you wouldn't be wrong on a free response question. But if I divide c by 3, what do I get? Just another c. So it probably look like this on a multiple choice question. And then when I divide the 3 also into the 9. So that's how it would look on a multiple choice. Or maybe that whole, but if it was free response, you could put that whole thing over 3. You could have a c over 3 and a 3. Lots of different options that they would accept on free response, because they don't need you to do anything more than solve for y. the simplifying part is not as important to them. Make sense? So that would be the differential equation for that. And if you had done it the other way, the main difference is actually, I think it would have actually looked exactly the same. Now that I think about it, you would have just had a y minus 3 here, but you would have had what? 6x squared minus 15x. You'd had something different there, but still would have ended up being the same. What else? Anybody else on anything? Y'all see how to do 6? Is it hard? You have to go through a bunch of formulas and solve, or can you just ln of half divided by a 30? And you know that if they ask you on a multiple choice test, you know that it's not going to look like that. What do you think it's going to look like? Well, possibly. It's not going to be ln of a half. It's going to be negative ln 2. Good. So it's going to be that. Do y'all see how? There's two ways you can think about it. One way is you can think about that. A log of a fraction is a log of the top number minus the log of the bottom number. Remember that log rule? But log of 1 is 0. So if log of 1 is 0, then that's equal to negative ln 2. Another way you can think about it is 2 on the bottom is the same thing as a ln of 2 with the negative 1 power. Swing the negative 1 to the front. But either way, if it was not a decimal, which it very well could be, on my test, I think I have one that has a decimal answer maybe, and one something similar that has a answer. But don't go pick none of these if you have that and you don't see it, because remember, AP loves to change 1/2, 1/3, whatever to a negative log. And I do that at least once a test. Yep.
So like 1/5 would be like
negative ln 5. Good. Yeah, you just see that a lot, which is a little annoying for me, but whatever. I talk about it enough that most of my students remember that. They're okay. Anybody else? Anything? Feel good? All right. We can't do this because we never learned integration by parts. I left it in there, and in the rare event things go back to normal and we actually have extra time, we don't have to slow down and lose stuff. But that is an old question from probably modified from an old AP test when integration by parts was needed in AB. But it's needed, right? It's somewhere in here. It's needed. Maybe this part. Yeah. So just don't worry about that. I don't think I signed it, but just don't worry about that. Okay, so we have talked about the slope fields. Does anybody, hopefully we feel a little bit kind of okay on that. Is it 57 I want to be on? No. I mean, there we go. Yeah. Look at, did anybody start looking at these? Any of these teaching series questions you want to talk about? I don't think we have time to talk about all 14 in class. We might. Are there any of those that y'all want to look at? I've got an AP problem or whatever that we can take a look at. There's really nothing else out there except to see different ways I might ask questions and kind of prepare you for your test that's coming up next week. But looking at these, anybody? Or were you able to do just all of them? Because if you could do all of them on your own, that's 14 AP questions that popped up over the years. That's pretty great. Guessing you probably didn't. Really? Y'all were able to do all of them? So which ones could you're all like fourth period. Stone cold silent. Yeah, talk to me. I can go individually. Can I do number one? Let's look at number one. If the derivative of that is negative 2y, and if y is 1 when t is 0, what is the value of t for which y is a half? What do you think I need to do? Solve the differential equation. Now, I know you see BC there. Sometimes people see BC and they go, oh my gosh, that's a BC question. How do we expect this out? 70% of the AP test that's for BC is our test. They just literally take 70% of ours, they put it in theirs, and then the last 30% are BC topics. So literally, if you didn't know any BC topics, and you did fairly well on the AB part, you could get an AB subscore. So literally, you guys could go in and take the BC test, just like you take the AP test. And if you made a certain point value, now you'd have to do really well because you still have to hit that point value, right? But you would get an AP subscore. So they would ignore the BC part and say, oh, okay, let's just see if we can at least give them credit for AP, AB. And sometimes that happens. Somebody will fail on BC, the BC part, make a 2, but they might make a 4 on the AB part, and at least they get credit for Cal 1. But on this one, they never said solve the differential equation, but you're going to need that differential equations with y's and t's in it to be able to get somewhere with this. So again, be aware, these are other ways to ask, solve the differential equation or find the general or the specific solution. So right here, this shouldn't be a big deal. What are you going to do first with this differential equation here? Talk to me. Okay, what are you gonna move?
The Y.
I'd move the y. A lot of times people move the negative 2y, and then that makes them have to do a u substitution. Don't move what you don't have to move. Now, if something is joined by addition and you can't factor it, well, then move the whole thing. But if it's joined by multiplication, it's really not joined. Okay, you can move one part, both parts. So I'm just going to move the y down by dividing both sides by a y. And I'm going to multiply both sides by a dt. So that negative 2 is sitting over there in complete harmony, right? So when I integrate, and I can leave that constant on the outside, that is a rule, right? 1 over u du. So I don't have to do a u substitution, which is kind of nice. And that would just be negative 2t plus c, exponentiate. And you get absolute value of y equals big C times e to the negative 2t. And of course, the absolute value part goes away. Now, at this point, I think it would be a good idea to kind of start finding your C value, right? So they gave me 1 point. I didn't need to find a K value, so I don't need 2 points. 1 point will do it. When y is 1, and I'm going to write 0, 1, right? Because there's t, and then there's y. So when I plug 0, 1 in there, I get 1 equals c e to the 0, so c is 1. So here we go. Y equals c e. Y equals 1e to the negative 2t power. So there's my equation. That might be the question. Find the equation. But in this case, it said, what is t when y is a half? So if y is a half, what am I going to do to solve? I ln both sides, and I get ln. Ooh, here's an example right here. ln of 1/2 equals negative 2t. And then what do I do? To finish it up. And why don't I see that answer? Because ln of 1/2 is a negative ln 2 over a negative 2. 2 negatives cancel. Bam. So this is a great example of how somebody might do all their work right and get to here and look up there and go, I don't know what to do on this. And I tell you, a lot of people pick this, the ones that miss it, because they're thinking, oh, maybe I made a careless error. It's got the negative 2 in there in the log. I probably made a careless error. And they go with A. And they miss all of it. Now, in my test, it'd be like a 3 or 4 point problem. So if you had showed all your work and got to here and not picked that, I would give you 3 out of 4. But they're not going to do that on an AP multiple choice question. You're just going to miss it all. So be careful about that thing. It shows up a decent amount like it did in 1985. My junior year of high school. What else? Look down there. So if you haven't done them, you need to do them. These are all tons of my math questions, my test questions in the years past have come from these. Just changing numbers and stuff. Sure. Okay, so number 10 gives you a differential equation right here. It says when y is 1, if y is 1, when x is 1, then what is y? So it kind of like is the same question I just asked, but with something a little uglier. So right here, what do you think you ought to do? Oh, yeah, you would need a, that's definitely BC. You would need a little integration by parts, or you'd have to have your log rule memorized. So this is not something that would actually show up, because on this right here, you're going to have to integrate natural log of x. You can, but that's something we memorized. But the way to do that is integration by parts. So you shouldn't see that on the AP test. I put it in there because there are a couple things I want you to know. Just because it's not AP doesn't mean it's not going to show up in Cal 2 and they're going to expect you to know it. And it's a pretty easy one to memorize. So like what Selah said, that there is an integral rule that you learned, but because the way to do that is integration by parts, it shouldn't be asked on the AP test. But we'll just walk through it. Right here, I can slide the y down. That would give me dy over that y on. That would give me dy over that y, and I can multiply by dx, and that would give me 1 plus ln x dx. And if I integrate that nicely right here, I just get ln absolute value of y. Integrating a 1 gives me a x, and integrating an ln x gives me what? You remember your integral rules? Plus c, right? It's minus x. It's minus x? God, even I forget. X ln x minus x. That's right, they do cancel. It's not. So right here, when I exponentiate both sides, I get absolute value of y, swing the c up, and that gives me e. And when you swing the c up, it's now here. Those x cancels, and you get x ln of x. And then when you solve for c, what happens when y is 1 and x is 1? When y is 1, x is 1. That only gives you a 0. X is 1 right here, gives you ln of 1, which is 0, times 1, which is 0. E to the 0 is 1, so your c is 1. So you end up getting this 1 e to the x ln x. And you already knew that the absolute value got eaten up by that c anyway. So you end up getting E. But yeah, this is something that I wouldn't be asking on a test. But like there are integral rules that we have talked about. Like AP only asks stuff with like inverse sine and inverse tangent. But you go to Cal 2 at Auburn, Alabama, Vandy, whatever, they expect you to know all the inverse trig derivatives, all the ones that they expect you to know it all. So I teach some things, but I only require you to know some things test-wise. Yeah, 11. dyt equals ky. What do I see there? When the rate of change of y is proportional to the amount of y. Yeah, so this is, if it was x, I couldn't do this. But because of that, y and y, or dy and y, I can kind of skip the process. And I can jump straight to y equals ce to the kt. It says k is a non-zero constant. If k is a non-zero constant, then y could be equal to what? What could y be equal to? Yeah, right? It can't be equal to kty. There's no t there, right? It's not going to be equal to plus 3 because the c value is times c. It can't be equal to this because there's not even an e in the problem, or this, right? So I really have no, that's the only thing. C could be 2. It's possible. I don't know what my initial, my point for the differential equation, we talked about how there's all kinds of points that give you different equations, right? That make the graph sketch differently. So I don't know what point they're talking about, but they just said, what could it be? And yeah, there's probably a point out there that would make c equal to 2, right? I know that the point 2, 0 does. So that's totally possible for that to occur. But it is not possible for any other ones to show up. There's no way I can pick a point and plug it in there and get something that's plus 3 or get suddenly a t, a y, sorry, not a t, a y appears at top. Just doesn't happen. Yeah, it would just never happen with any of these. What else? Look at 12, 1998. I know that's a long time ago, but they give you all this big problem about population grows according to that. Ooh, that means it's exponential growth. Y equals c to the kt. They tell you K is a constant, T is measured in years, the population doubles, blah, blah. They're giving you all this information, but do you really need it? Because what do I know about finding K? If it's y equals c to the kt, if it is, which it is based on that differential equation, then I know that K can always be found by what? Logging the rate at which it's growing or shrinking, and it's doubling over how long it takes to do that. And you would just type that in your calculator and whatever it spits out. What is it? Yeah, because that's a little bit smaller than 1. Log of a 2.7-ish of 2. It's pretty close to 1, and 1/10. That's pretty close to 1/10. It's a little bit big. But you'd have a calculator to type that in. What else? Well, here's a great slope field question. All right, so you got a slope field question. Is there anything I could do to maybe eliminate some of these options right now? Anything that has just an X or just a Y, I should be able to eliminate. Why? Because I
like the same horizontal and the same vertical.
Yeah, I don't see the same vertical or the same horizontal slope, do I? So if I see them changing both ways, then it has to have an X and a Y in it, which means I can cancel that out. I don't even have to look at it. Come on, man. I can cancel that thing. I can cancel that thing out. And I can cancel that thing out, which is pretty great because now I'm only down to 2. I mean, and that is a BC question. I got to be honest with you, they always seem to be a little bit trickier than that now. You usually can't eliminate that many and make it just a coin flip, you know? But at this point, what do you think? You could just start plugging in numbers, but is there something that jumps out at you? I can see a couple things that when I look at these two equations, they jump out at me as checks. They do here. They don't here.
There's like some positives and negatives in the same word.
So give me an example. Because if they're both positive, which they are here, positive X, positive Y, you get positive slopes.
But then in the second quadrant, some negative.
Okay, so here I know that every X is negative. I know that every Y is positive. So if every X was negative and every Y was positive, I should have negative slopes in that whole quadrant, shouldn't I? But you can see I have some negatives and some positives. That's a great thing to notice. Okay, so it can't be this right here, can it? Give me another thing that you could notice, because I actually didn't even think to do that because I saw something else I thought might be quicker to check. What about right here if Y is 0? That means what? Hold on, Y is 0 is what? Right? Y values of 0 are x-intercepts. So right here, I should have what kind of slopes? If Y is 0. It should be undefined. When Y's are 0, it's undefined. So, but you can see that clearly, well, to me, clearly, it looks like the curve would be going right through there, right? I mean, right here, it's even getting slow. Right here, it almost looks like it's flattening out. Right here, it looks like this. These should all be totally vertical. Right there, or you should which basically means you should see nothing and it should look like it's going vertical, either maybe like this or like this. I don't see that, do I? Or on the flip side, what happens when X is 0? X is 0 are all of these, right? 0, 1, 0, 2, 0, 5, 0, -6. What should all of those slopes be? 0 slopes, and those aren't 0 slopes. Maybe there it is, but not up here and not down there. So there's a lot of ways I can eliminate that thing. And then what's a way of confirming this thing? What happens when X and Y are opposites? like -2 and 2 or 3 and -3. You get zeros. And if you look at these, every one of these little, no matter what point I pick on this, no matter what point, it looks like the graph is doing this, doesn't it, on all of these? Kind of looks like it's going like this. And if I really think about it, if it looks like it's doing this, opposite x's, like 1, 1, 2, 2, it looks like it's going to 0 on all these. -1, 1, -2, 2. It looks like I'm getting 0 slopes on all those, which I should if they're opposite. So anyway, have a plan for all of that. If you don't check the, like you said, if you don't check the O, if it only has one variable, then it would have to have the same slopes. Then you're now having to think about all 5 of these. So you usually can eliminate 1 or 2 that way. It's rare that you can go to 3. But this is the way it would look like. You're not going to see a matching problem with 5 slopes and 5 equations or that. You're going to see this with 5 of these, or I think there was one above where you see stuff like this, trying to match it up with one of these. And by the way, can you do this? This is a good question. Good question. What's this saying? Number 11 says the graph of the derivative is there. So that's the derivative curve. Are you with me? Now, it's evidently the derivative curve of a very particular situation, right? It's not doesn't have a C in it because it just had one. It's like somebody took the derivative, you got a new curve, and somebody sketched the curve. And we have done that, right? We've taken y's and graphed dy or dy dx's or y primes. So there's the y prime or the f prime of x. If that's the derivative, what would be the function? So hold on. This is the derivative. So what does this mean? Right here you have what? Right here you have pen. Right here you have positive what? Positive slopes. So from -2 to 2, if the derivative is positive, what's happening to the function? Function's increasing, right? Remember we did those little analysis, like if I think we did it like this. If f is increasing, then the derivative of f is positive, right? So where do I see positive derivatives from -2 to 2? I'm sorry, where do I see f increasing from -2 to 2? E. It's the only one. Now, sometimes you'll get it. Well, I think it's the only one. Hold on. Nope. -2 to 2, it's increasing, right? But that means it should be what? Decreasing there. The function should be decreasing there, and it's increasing there as well. So even though it was increasing here, right there, that part was okay. This part wasn't. Well, it's not super okay, but it's relatively okay if that's all you were checking. But you can see on E right here, I was increasing on the function from, and this is just loaded, from -2 to 2, but I was decreasing everywhere else.
Sure. Did you integrate that equation with that graph?
What's the equation of the graph?
The equation of the derivative, like the top.
Yeah, what's the equation? I'm not saying it's a bad idea. What's the equation?
Well, it's got to be -x squared.
That's it. Is it? I'm just saying, be careful. You could make that assumption and maybe get somewhere, but is it possible that you just see a small part of it? It's possible. Now, listen, I'm not saying it's still a bad idea, because properties of a what? That would be like a -x squared, maybe up to, right? So if this is a dy dx graph, I'm not saying it's a terrible idea, because check it out. If you are able to write something like that down, and integrate, what do you end up getting? Some negative cubic graph. What does a negative cubic graph look like? Maybe like this. This would be a possibly a Actually,
Maybe.
be more like D, wouldn't it? A negative, did I do something wrong here?
No,
Negative x squared plus 2. Sorry, negative x cubed over 3, sorry, plus 2x. That should look more like this.
Not necessarily, E's one.
Oh, sorry, you're right, yes. So, okay, good. Yeah, so this actually does look like a, sorry, I was thinking that was it. This does look like a negative x cubed, right? Because negative x cubed graph should go down to the right, not to the left. So yeah, it could be, but actually think about that. If that was that curve up there, if it was a sine curve, if the dy dx was an actually this would be a positive cosine curve. If the dy dx was, what would be the integral of that? It would be integral of cosine is what? Positive sine of x. And guess what? Doesn't that kind of still look like a positive sine curve? So yeah, you could think either way, but I would encourage you maybe not to think about the graph, because sometimes you could, especially if you integrate wrong, you might get thrown off track.
Yeah.
What else? Anybody else on any of these? Getting a lot of blank worksheets. I gotta wake up, man. Woman. 8. All right, during a certain epidemic, the number of people that are infected at any time increases at a rate.
Oh, wait, no.
Not that 8.
Sorry. It was number 13. It was like 800.
I got you. All right, 1998 BC number 8. If the derivative is that, and if y is 0 and x is that, what is the value of y when x is 0? So again, I'm looking for an equation so that I can actually have a y and an x. You're going to have to do some sliding around here, right? Well, actually, not much. So you get dy, and when you multiply by dx, sine x, cosine squared x, dx. Now, I know for a fact that I have given you problems just like this, and people are still messing them up by doing this. They'll go, oh, u is sine, and then du is cosine x dx, and they go, there's my u, and there's my du. They were writing that. Do you really want a du squared in your problem? And not to mention, it's not even du squared. It really, that right there means this. It means cosine x dx, doesn't it? So if you think this way, you're really doing this, but you still have an x left in your problem, which is a problem. So don't circle it up and make that your u and your du. Be careful and do what? Okay, so if you have sine x cosine squared x dx, let your u be cosine of x. That you can do. And then let your du be what? Negative sine of x dx. Go back and brush up on your integral and your derivative rules. I know everybody knew that when we did derivatives. You knew your rules. And then we switched to integration, and then it messed you up a little bit because you were kind of going backwards with the signs. But you got to be fluid both ways on this, right? The derivative sine's cosine. The integral of cosine is sine, right? So derivative of cosine is negative sine. So I'm going to have to put a negative in there and a negative on the outside to be able to make that my du. So at this point, I get y. I'm going to go ahead and integrate that part. U squared du. So this gives me y equals u cubed over 3 plus c, where the u is cosine x. So what do I do with that thing? When pi over 2 is your x, your y is 0. So I would probably say pi over 2 comma 0, show the reader or whatever that I'm plugging that in, plug a 0 there, what is cosine of pi over 2 when you cube it? Yeah, pi over 2 is straight up. The x value straight up is 0. So I end up getting c is 0. It's kind of nice, right? So my y is just cosine basically cubed x over 3. And then it says, what's the value of y when x is 0? Well, what happens when x is 0? It's 1. 1 cubed is, so I'm basically now saying when x is 0, when x is 0, what do you do? So when x is 0, I get y equals 1 cubed over 3 or 1/3. And on your test, I realize that some of you get an answer before you write stuff. Like I realize how you function. Like you'll look at this and you're like, you just eyeball it and you're going, oh, if I plug it in, I get 1/3. Okay, you start my answer. Remember, I'm giving you points for each thing you're showing me. Are you with me? So I'm looking for you to show me, hey, I plugged this in and got this. You make a little error there, you miss your answer point, and your plug in x equals 0 point. Right? If you accidentally say, oh, cosine of 0 is 0, right? But if you show me the steps and how you got to each one of those, you increase your chance of getting your full credit. Remember, you got to get away from that. I'm working until I know the answer. You're working to show every step and the answer. Now, on the regular, real AP test on the multiple choice question, who cares? Scribble all you want. Just get an answer, move on. But on my test, I'm grading every question point by point by point. What else?
Mr. Ray, why don't you kick back and relax?
Not what I'm paid for.
You got tenure.
I've got tenure. That would make me a loser. Like, yeah, if I just said, oh, I got tenure to do the one of you. That's flat out that. Right?
It's assuming the position.
All right, 1998, BC, free response question. You'll probably have 3 to 4 questions just like theirs on the free response. They usually have 2 to 3 that are different. All right, so right here on the axis provided, notice how right here, they said on the sketch a slope field at the 12 points indicated. Don't sketch anywhere else. A lot of times they'll have like this, just to show you what it might look like. On pen. Okay, a lot of times they'll have these points like this. They won't be red, but you'll have all these points on the graph, right? And you'll see them because they'll be bigger than the other ones. And then they'll have nothing there. And if they don't have anything there, guess what probably happened there? It was undefined. Don't do anything with that. Only mess with the big dots, the points that are provided. And they're usually a lot fatter. I created this, but they're usually a little fatter. And you can clearly see that that's what they want you to do. So they asked you to sketch the slope field for this thing and then find a particular solution, yada, yada, for the differential equation. So what are you going to do on the slope field here? What are you going to start with? By the way, don't use the points I used. Oh. So starting with -1, 3. What's -1, 3 going to give you? What's the slope? -3 over 2. So I'm going to go down 3 over 2. So you want this thing really going like it's going to go all the way through that, except you're only putting this part, right? But you're visualizing, sorry, -3 halves, down 3 over 2. So you want it to look like it's doing that, but you only want that little section in there. But make sure, line up. Dang it, I was right. I am losing my mind. A rough day today. Down 3 over 2 is right. Okay, so down 3 over 2. Next, -1, 2. -1 should be pointing right at that point right there, -1. What about -1, 1? Down 1 over 2 should be pointing right at that point. What about -1, 0? 0. What about 0, 0? 0. What about 1, 0? 0. What about 0, 1? 0. What about 0, 2? 0, 0. You know how they gave you points on this? You got 2 points credit, 1 for getting all the zeros right, and 1 for getting all the other ones right. And if you do the other ones, you end up looking at, you look at something like, hold on, 1, 2 gives you 1, yeah, and then that gives you that. So it kind of looks like this image.
Does it matter like how
It needs to look on the slant like this was down. This slope here was 3/2. It needs to be pointed at down 3, left 2, or up 3, over 2. So you need to visualize. It is really important when you visualize it that it is literally moving right at that point. But you only want that part of it. Hey. Stop.
Yeah.
I'm sorry, can you say it again? Yes. Sure. Check it out. All right, so that's my slope. We got a couple more minutes. Find the particular solution. When that occurs, use it to find that. So, guys, this is all day long in your AP test. 2 points for this, maybe 3. No, I skipped part B. Part B, evidently, you didn't know enough to do, so I didn't bother putting it there. It might have asked some other random thing. So that's a 2-pointer. Part B was probably a 1-pointer. This thing, find the particular solution. On every single AP test but one over the past 10 to 12 years, including practice tests, you've had a 6-point question like this. That is the biggest chunk of points you'll get on the test for one question. And they're not difficult, right? Solve dy over dx. So dy over dx equals xy over 2. Show every little step. So first step is what? Divide by that y. Second step is multiply by that dx. You get 1 point for that. Just for doing that. And whatever, you could write it as 1/2 x, probably look a little better. But then integrating, you get no point for writing the actual integral. But if you integrate this and write ln absolute value of y, you usually get a point or maybe a 1/2 point. Depends. And then on this part, this is 1/2 x. So how do you do this? X squared over a 2 times 2. So x squared over 4 plus c. You usually get a 1/2 for that and a point for remembering to put c. Or sometimes they say you get a point for ln y, a point for x squared over 2. But if you don't put a plus c, we cap your points at 2 points. They literally steal a point back from you. So you have, they'll say it on every one. They'll say maximum of 2 points if the c is not written. Okay, so at this point, you're already at what, 3 points? So you're going to e both sides. You're going to put absolute value of y. You're going to swing the c. And you actually get really no points at this point. But now is where I'd probably find my c. So at the point 0, 3, if I plug that in there, 0 squared over 4 is 0. E to the 0 is 1. C is 3. Oh, by the way, I would have let the absolute value be consumed. The plus or minus part be eaten up. So I end up with y equals 3e to the x squared over 4. And you get a point, sorry, for that and a point for this. So at this point, we're at 1, 2, 3, 4, 5 points. The last point you get is for answering that question. So this is saying if you had a function, which I do, plug 0.2 in. So since they used f, y is f, right? Then I'm going to say f of 0.2, and I'm going to plug the 0.2 in. Now, they expect you to be able to simplify a little bit on a multiple choice. But honestly, if you left it like this, you're going to get credit. But I like cleaning stuff up. So what is 0.2 squared? 0.04. You can say the 0 in front if you want. And what is 0.04 over 4? 0.01. So you get 3e to the 0.01 power. But on a free response, if you're taking this on the AP test and you're like, I forgot how to square decimals, or you have a brain freeze, don't try to do something that would lead to an error. Just stop. It's the multiple choice that you're going to have to get your answer matching one of the ones that they've given. So that's totally fine. And that's your last 0.1. All right, guys. So you had your homework for tonight was to look at the 1987 and the 1983, those two AP problems. Do those. I'm skipping a homework check. Okay. I want to see, and I want you to do this. I want you to do it on, y'all listening? I want you to do it on your own and then I want you to grade it like in a red pen or in a different color. Find another color or something. On the homework problems for the night, I want you to do the best you can, and then I want you to check and correct. The keys are up just so I can see where you are. All right? And hopefully you're in a good place. We don't have a whole lot else to do. I've got one more slope field quiz for you. Over the weekend, a couple AP problems we're going to work on tomorrow in class, and then a review and a test Monday, Tuesday, Wednesday. Say again. What's in the can? Oh, that was a homework problem from last night. Today, Thursday. Oh, from Tuesday night. Yeah. Homework problem. Might show up on a test. Who knows?